Scene script. Have you ever wondered what keeps our massive skyscrapers and bridges from sinking into the ground? The unsung heroes are the footings. A footing, in the world of civil engineering, is a vital structural element that carries the weight of a building or structure and responsibly transfers it to the soil or rock beneath. Picture footings as the sturdy and dependable shoes of a structure, ensuring balance and stability. Footings bear the brunt of the building's weight, and they distribute this load over a large area. This distribution reduces the stress on the underlying soil or rock, preventing the structure from sinking or settling unevenly. It's an unsung hero, working tirelessly beneath the surface, out of sight, yet playing a pivotal role in every structure's stability. The functionality of footings doesn't stop at supporting the weight of a building. They also play an essential role in resisting different types of forces and moments that a structure may experience. These forces could be due to earthquakes, wind, or even the weight of the occupants and their possessions. Footings are designed to resist these forces and ensure the structure remains safe and stable. The type of footing used in a structure depends on a variety of factors. A footing's design takes into consideration the soil conditions, the load-bearing capacity required, and the building's structural design. It's not a one-size-fits-all scenario. Each footing is carefully designed and tailored to suit the specific needs of each structure. Footings are a testament to the precision and complexity of civil engineering. They are a fundamental part of every structure, whether it's a towering skyscraper, a sprawling bridge, or a cozy family home. So, next time you're admiring a magnificent building or crossing a sturdy bridge, remember the humble footings. These unseen heroes are working tirelessly beneath the surface, ensuring the safety and stability of the structures we rely on every day. So, without these crucial elements, our buildings would be less stable and secure. There's no one-size-fits-all in the world of footings. Let's delve into the different types. First off, strip footings, also known as continuous footings, are long, unwavering concrete pads that support a line of columns or walls. Imagine them as the pillars of strength in buildings with load-bearing walls. Next, we have spread footings. These are individual concrete pads that support a single column or point load. Picture them as the stoic sentinels commonly found in residential construction and smaller structures. Then, there are mat or raft footings, which are vast, continuous concrete slabs that cover the entire area under a building. These come into play when the soil has a low-bearing capacity, spreading the building's weight over a larger area like a well-crafted raft navigating a river. Moving on to combined footings, these are used when two or more columns are so close together that a single spread footing won't suffice. They are uniquely shaped to support multiple columns and are designed to distribute the loads efficiently. Strap footings are an interesting blend of a strip and spread footing. They are used when one column bears a significantly larger load than the others, and the strap connects this heavily loaded column to a strip footing supporting the adjacent columns. Then we have pile footings. Here, piles or deep foundation elements, such as driven or drilled piles, are used to transfer the building's loads to deeper, more stable soil or rock layers. These are the go-to footings in areas with not-so-great soil conditions. Caisson footings, also known as drilled piers or caissons, are cylindrical or rectangular deep foundation elements that are drilled or excavated into the ground to support heavy structures or bridge piers. They are often the choice when dealing with challenging soil conditions or when a structure needs to be elevated. Finally, we have slab-on-grade, a type of footing used in residential construction where a concrete slab is poured directly on the ground without any deep foundations. It's the perfect match for lightweight structures, like single-family homes. These different types of footings are designed to cater to various soil conditions, load-bearing capacities, and structural designs. Choosing the right footing isn't a game of eeny, meeny, miny, moe. There's a lot more to consider. Every construction project is unique, and the choice of footing hinges on a multitude of factors. Let's delve into these aspects and understand how they influence the selection of the ideal footing type. Firstly, soil properties are pivotal. The strength, consistency, and behavior of the soil under different conditions directly impact the type of footing chosen. For instance, if the soil has a low bearing capacity, it may be necessary to use a mat or raft footing to distribute the building's weight over a larger area. Secondly, we consider structural loads. The load-bearing capacity required by a structure is a significant factor. A single-story residential building might get by with isolated spread footings, while a multi-story commercial building might necessitate the use of combined or pile footings to transfer the load to deeper, stable soil layers. Thirdly, the building design plays a significant role. For example, if the structure has a line of load-bearing walls, strip footings are typically employed. Alternatively, for buildings where one column bears a significantly larger load, strap footings can be used. In essence, the design and configuration of the structure largely dictate the footing type. Lastly, local building codes cannot be ignored. These codes are formulated based on local geological and climatic conditions and must be adhered to ensure safety and compliance. For instance, in regions prone to earthquakes, certain types of deep footings might be mandatory. In this complex decision-making process, the role of a geotechnical engineer is crucial. They evaluate the soil conditions, study the building design, consider the structural loads, and take into account the local building codes. Based on their comprehensive analysis, they recommend the most suitable footing type for a specific construction project. Remember, footing isn't just about supporting a structure. It's about transferring the load safely and efficiently to the underlying soil or rock. It's about ensuring the safety and longevity of our structures. So when it comes to choosing the right footing, it's definitely not a game of chance. Selecting the right footing is a critical step in ensuring the safety and longevity of our structures. In the grand scheme of civil engineering, footings might seem like small players, but their role is anything but small. They are the silent keepers of stability, anchoring structures to the ground and bearing the weight of our architectural marvels. We've walked you through the different types of footings, from strip and spread footings commonly used in residential construction and smaller structures, to mat or raft footings designed for soil with a lower bearing capacity. We've also discussed combined footings and strap footings designed to efficiently distribute loads in complex situations. And let's not forget pile and caisson footings, used when soil conditions are challenging, and slab on grade, a simple solution for lightweight structures. Each footing type serves a unique purpose, selected based on factors like soil properties, structural loads, and local building codes. So, next time you marvel at a skyscraper or a bridge, remember the unsung heroes, the footings that keep them standing tall.